All right, so for the last lesson, we're talking about the big one, oil and natural gas. So they get a bad rep, and there's a reason for it. But, we rely heavily on oil and natural gas resources. And it's pretty complex how we get these resources. So crude oil is like raw petroleum. It's unrefined. Crude oil is pumped from wells in the Middle East, West Africa, Americas, and Asia. It's pumped into ships, transported for refinement into a variety of products. So they're going to go to a oil refinery, and that's where they're going to turn it into the usable gases and types of petroleum that we use today. So products made from crude oil are gas, diesel fuel, jet fuel, kerosene, and a lot of other derivatives. Crude oil is a complex mixture of hydrocarbons. It's made of hydrogen, carbon, traces of other substance. Petroleum-based products have a relatively significant carbon dioxide emission, but this can be reduced through the use of improved engines. Diesel trucks back even 20 years ago, they had a lot different engines than the ones that they have now, just in how they process carbon dioxide emissions. So according to the U.S. Energy Information Administration, natural gas is a gas that occurs deep beneath the Earth's surface, consists mainly of methane, which has one carbon atom and 4 hydrogen atoms, contains small amounts of hydrocarbon liquids and non-hydrocarbon gases. Natural gas can be used as a fuel or to make materials and chemicals. Natural gas is increasingly common choice for home heating and other uses in the United States. It offers lower carbon dioxide emissions than oil or petroleum. So to find both of these, they're extracted from wells deep into the earth. Advanced science techniques are used to locate oil and natural gas deep beneath the Earth's crust. So I'm looking for natural gas geologists. So if you want to do any of this, you're going to go study geology. They use seismic surveys. You've probably heard seismic from like earthquakes. Seismic surveys rely on echoes from the vibration source at the Earth's surface to gather information about what's below. In many cases, a truck with a mounted vibrating plate provides the source of vibration. Explosives can also be used. Finding oil, they can do a lot of different things. They can use aerial surveys, gravitational analysis, and acoustic surveys. An acoustic survey, acoustic is sound. They use an air gun to fire pulses of sound into rock and then measure the response to the sound of the rock. Information is combined into 3D visual to allow them to see if there's potential for oil. Today, these assessments have increased the likelihood of successful experimental drilling from less than 10% to around 50%. So there's a lot less just drilling and hurting the environment for no reason. We're actually getting more accurate and precise. As with mining, before any additional work is carried out, appropriate environmental studies are completed, along with studies on economic viability. So drilling may take place in land or at sea. There are oil rigs all in the sea. Those of you that live in Houston, you know what I'm talking about. On land, roads, and utilities may have to be put in place before work can commence. There are 3 different types of drilling rigs at sea, depending on the depth. There's shallow, rougher and deep, and extreme deep water ones. Once all equipment needed on land or at sea is in place, an exploratory well is drilled. So that's just to see if it's a smaller well to see if there actually is gas or oil. And if it is, then they're going to test it and they're going to start actually extracting the oil and the natural gas. So improved technology has enabled the extraction to get a lot more oil from the oil wells. For many years, only 10% of the available oil was extracted from a given well. Today, approximately 60% can be effectively removed. So there's primary recovery, secondary recovery, and enhanced recovery. Primary accesses around 10% of the crude oil, relies on natural underground pressure to drive fluids. It's really common in offshore drilling. Secondary is the most common. Water from the oil drilling process is pushed back into the oil well In addition, the boosting oil recovery eliminates concerns over generated wastewater. And then there's enhanced. They remove significantly more oil. Thermal recovery relies on steam to bring more oil to the surface. Gas injection uses gases to thin the oil or to increase the pressure in the well rather than relying on steam. There are risks to the environment. Traditionally, drilling in the oil industry poses some environmental risk. Many of the existing oil reserves in U.S. and Canada are located in environmental sensitive areas and like protected wilderness regions. So that could be a problem. There has been steps to reduce like dangerous spills at sea or transportation. Some areas, such as the Arctic, additional measures are in place to reduce the risk to the environment. Like in the Arctic, oil exploration is limited to the winter months when bridges, roads, and other construction can be put to use without damaging the land. Fracking, you've probably heard of. Natural gas is most commonly extracted today by a process called fracking or hydraulic fracturing. So hydraulics use fluids, like we talked about last unit, um, under high pressure to produce power. So fracking uses a high pressure steam or water, sand, chemicals to force natural gas and oil from the rock. It's really controversial. People have their own thoughts on it. It uses a lot of water, which is a concern with our water supply. Chemicals are used in the fracking process that can contaminate local groundwater. It's been linked to increase in earthquakes, although it rarely is going to cause earthquakes. The disposal of contaminated fracking water in deep wells has been linked to a much larger number of earthquakes. So advocates of fracking note that the U.S. has really boosted domestic oil production and driven down gas prices through the extensive use of fracking. It's estimated that fracking has offered gas security to the United States and Canada for as long as 100 years. In addition, access to large supplies of natural gas has offered an opportunity to generate electricity at half the carbon dioxide emissions of coal. So then we got our questions. What is the most important forest resource? That's going to be wood. What are cellulose nanocrystals used for? They're light, strong building materials. And what is the overall effect of small organisms that live in the soil? They make it fertile. So they help with the soil, making it fertile. So in summary, natural resources, they range from renewable energy sources such as water and sunlight to non-renewable like oil and coal. Um, Laws and sustainability are all important when it's coming to um, regulating these resources in our environment.